If you know what CMake is, then go ahead and skip ahead to this time to see how to use it. CMake is a build system. Similar to an IDE, it's going to manage your dependencies and it's going to build your executables for you. And so there's some setup we have to do. Before we actually start getting into what this code here means, let's go ahead and move to our file system. Go to your project root folder. And you're going to want to create a setup similar to what I have here. You're going to want to have a source directory. This is where you'll put your source files. For me, that's terrain generate. You want to have a build directory that's empty. You want to have a dependency directory. My dependencies are EasyBMP and fastnoise2-master. EasyBMP is how I can operate on bitmap images. It's a bitmap image library. And fastnoise has all sorts of algorithms for creating continuous terrain, like Perlinoise and others. And the program I'm building here is a terrain generation program. Yours will probably be different, but the process is still the same for linking external libraries. And then you'll want to have an include directory. And this is where you're going to have all your header files. Okay, so once you have this file set up, and this .git, that's just because I'm using git for source control. You don't have to have that. That's just optional. And you want to make this text document here a CMake lists txt file with the same case here, capital C, capital M, and a capital L on lists. And this is going to be the file that is accessed whenever we call the command CMake to build our project. So let's go ahead and jump into that. I have it opened up here. The first thing you want to do on your CMake lists file is this first line here, CMake minimum required with a version and a number. This is going to tell CMake what version you're going to be using. And you want to use a version that's close to the most recent version. Right now I'm running version 4.0, and so I'm going to get version 3.24 because that's pretty close to 4.0. A way you can check to see what version you're running, you can go to any command prompt terminal. You can type CMake -- version, and that will tell you the version that you're running. If you don't have it installed, then I'll show you an additional install tutorial. It should be linked somewhere around here. Go ahead and watch that if you don't have it installed yet. Okay, here on line 4, we need to declare the project name. And if this was a dependency of another project, then that CMake for that other project is going to reference this name here whenever it's accessing this library. This is not a library though. This is my main project. So I'm just going to give mine a name, and that's how I'm going to refer to any kind of compiled binary from my project from here on out. And this is necessary in every CMake list file. All right, and then on line 6, I'm just setting what version of C++ I'm using. And this set command here, this is kind of like setting the value of a variable. This CMake _cxx _standard, this is a variable, and I've passed to it the value 14. We can declare new variables in CMake with the same set function. An example will be if I wanted to create a variable called dogs, and I'll put it in capitals to keep the same convention. And let's say I wanted to store the number 20 in there. I can say 20. And now I'll store 20 inside the variable dogs. If dogs has not been created as a variable yet, it'll go ahead and create it. And it'll put 20 inside of it. That's what the set function is doing. Creating a variable and storing a value in it if it doesn't exist, and just storing a value into an existing variable if it already exists. Okay, so from line 8 and down, this is where the important stuff really starts to kick off. We have this function here called include directories. Remember before, I had you create this include folder that has all the header files in it. This line is going to tell your compiler and CMake where to look for those header files, because as it is right now, because this is my root directory and my source code is in a different child folder than the include folder, my compiler by default is not going to know where those header files are. So we need to move that, or rather we need to declare where they are on line 8 here. We're going to call the include directories function, and we're going to tell it where that is. Notice I have this strange symbol set up here. This is saying look at the project root directory. See how it says CMake source directory? That's looking at the directory that this CMake list text file is in right now. And so that is going to be my AI terrain 2D folder. And yours might be called something else. And so this is where CMake lists is in my project directory. So it's going to look at and assume that this whole folder is the root folder of the project. And that's what this money sign open brace CMake source directory is saying. Look at the root directory, and then relative to the root directory, go to the include folder. This is telling CMake my include file or my header files are in the include directory, which is a child of the project's root directory. And now it should know where those header files are. Down here on line 11, we have another set function. It's calling this variable, referencing it rather, CMake runtime output directory. And this is telling CMake where to put your binaries. Whenever you run the build function in CMake, that takes your project, it compiles the binary executables, and it stores them in the directory that you designate here. And that directory is /bin for binaries, and this is looking at the current build directory. Notice it's different from this right here. This is looking at project root directory, and this is looking at the current build directory. And whenever we call the CMake command, we're going to call that while we're inside of the empty build folder here. And when that's called, it'll create a subfolder called bin, and it'll store your binaries there whenever you actually call the build function of CMake later on. But this is important because it's telling CMake where to put your binaries when you build. Coming up here, we have some variables that have been set. This is referencing the fast noise library that I have as a dependency for my program. And these are specific to the library I'm using. Other libraries you might be using might have their own variables. To see where those are, you might want to visit their GitHub and take a look at the documentation there on the README or other setup documents they have and look for those there. But for me, I've set mine to off because that's going to increase the speed of compilation, or it's just tools I'm not using in my project. Down here on line 20, next we're going to add the subdirectory. We're going to tell CMake where my dependencies exist. And so I'm going to tell it where fast noise exists. That's inside of my deps folder, and it's inside the fast noise 2-master folder. The file path you pass in here, it needs to be a file folder that has another CMake lists.txt in there for this to work properly. And I'll show you what I mean over here. Jump to my file system. I'll go back up to the parent folder, down to deps, and now here we have fast noise 2-master. Inside of here, I have another CMake lists. And I didn't write this CMake lists. This is one that's been provided by the author of this library. And so if I open this up in Visual Studio Code, we'll get to see how they structured theirs. And here's their CMake lists. Looks like they're running version 3.7.1. And then down here, they have some sets. They have some ifs. This is basically looking at different architectures that we might be running this code on in terms of processors. And this CMake will build this dependency. All right, so next we have on line 21, another add subdirectory. We're pointing to another folder. I'll jump back to my file folders. We have EasyBMP, which is the bitmap image library that I'm using. And this one actually did not come with a CMake lists text document. You see one there, but that's because I created that one. This CMake lists text document was necessary because this library was written back in the early 2000s, and they just either didn't have access to CMake because maybe it didn't exist, or they just didn't make one for it because I don't know when CMake was actually created as a tool. But for whatever reason, it didn't exist, so I actually had to create it myself. And so I'll go and open that one up, which is right here. And this CMake file, this nested one, this one is going to be called whenever we do target link libraries later on. But we haven't done that yet. I'll go and show you what it does. I go ahead and I declare the CMake version. I give it a name. I call it EasyBMP, capital BMP, and that's referencing the binary that'll be created by it. And I've set the standard to 14 for C++. Down here on line 8, I include the directory CMake source directory, just telling this project that its root directory is the directory that this CMake exists in. And so basically this is recursively, or almost recursively, like calling another CMake.txt to solve and to build this sub library before we finish building our main library. And then this is important here on line 9. It says add library, and then I have easybmp static followed by the source file. And this is saying that this project, this line is saying that this is not my main executable. This is going to be a library that's going to be put on top of the main executable. So this line 9 add library function is necessary to put in our external library CMake lists, but not in our main one. Notice over here I don't have an add library. That's because this is not a library. This is the main part of my code. So I do this to designate this as a library. I'm building a static library, and all I have to do to compile this is just to pass in the easybmp.cpp file, and all the header files that this needs are already linked to it through this .cpp file, and they're already nested in the same file folder directory, and I'll show you that here. Notice we have header source files here. These are all for easybmp. I didn't have to declare an include directory. I could have if I wanted to, but this is such a small library that I just had to throw them all into this folder, and this works just as fine as well. And this can see those header files because it's in the same folder that the CPP file is in right now. And to compile this, I just had one source file, so I just put one source file there. If you have a more complicated library that you're writing a CMake lists file for, then you'll want to look up the suggested way to compile it on the website or GitHub, wherever you've gotten the code from the author, and they'll tell you how to do it. Because like here, I looked this up on easybmp, their website, official website, and they had steps how to compile this, and I kind of just followed those steps and put that here. But don't forget, you're building a static library, so put static, and easybmp is referencing the binary that we're building for this library. And so it's saying, build this binary as a static library from this source file. And it's easy as that. This is done running now, so we're going to jump back to here. Here on line 24, this is where we're actually going to start building our executable. So we call the height gen, and then we give it a list of source files, and I only have the one source file, so it's pretty simple for me. I just put the relative file path relative to the root folder of my project that I designated, or that is designated with this CMake source directory. This is implicitly applied as my root folder, and so relative to that I have src for my source code, and I have terrain generate.cpp, and I just have to compile this to get this guy right here. And then once we've added the executable, the last thing you want to do is take the binaries that represent your static libraries or your external libraries, and you just kind of want to add them onto the end of your existing executable or existing binary that you just created. And remember, this has to have the same name as our project name. We're going to say private, and now I'm going to smash this onto there. And then once easybmp is done building, it'll be put onto this, and it goes on to link this library, fast noise to, and it builds it onto height gen afterwards. The order that I build these for my project doesn't matter because these libraries don't depend on each other whatsoever. But for your project, if you have libraries that depend on one another, there will be some extra steps or some specific orders you may have to go with. But for me, it doesn't matter, so I just have it in any order. And then once we link the libraries, then the build process is done. And then this will generate all the make files and everything else that's needed for you to actually build the executable. So this CMake list.txt, this is not building the executable itself. This is saying how the executable is going to be built with whatever build system you're using that you designate. So just to recap, and if you don't need to recap, go ahead and skip ahead to this time here. But to recap, you declare the version. On line 4 here, you go ahead and you name the project. You set the C++ standard. You designate the include directories if it's not in your src folder, or if it's not in your source folder, you designate the include directories. And then you tell it where to put the binaries once they're compiled. you set any kind of different options for your external libraries you might want to set. You make sure to tell the build process where your dependencies are, just like I did here on line 20 and line 21. And then you go ahead and you tell it to add an executable to the build process, and the executable you're creating is your project. And after that, you're going to link your external libraries, and these target link external library function calls, they're going to go look for a CMake list.txt file. They're going to go look for that in the subdirectories that you designated here. And if it's not the case that there is a CMake list.txt file in that subdirectory, it should throw an error and it should fail to build. So that might be a problem you're experiencing if you fail to build. Okay, so recap's over. We're going to go ahead and build this. So I'm going to jump to my command line. Notice I'm already in my build directory. There's my users, my username, documents, and the programming file folders, AI train 2D, build. And that is the same as this build folder here. It's also empty. So I'll say dir just to see what's in there. And there's basically nothing in there. So now to build this, we're going to call the command. We're going to say CMake, not in all caps. To build this, we're going to say CMake. And now there's several generation types you can use. Me personally, I'm using minimum GNU on Windows, and so I have to designate that as my generator. But I'm going to go ahead and show you all the generators that are available, because you might be using something different. So to see the generators, you'll do -- help. And if I scroll up here, here it says generators. This is the start of all the possible generators we can use to build this. You have Visual Studio generators. There are some Makefile generators. There's a Unix generator. There's Code Blocks, CodeLight, Eclipse, Sublime. The one I'm looking for is a Makefile, and that is going to be minimum GNU on Windows Makefiles. Here it is right here. That's one I'll be using. And if you're like me, the title of this video, you're using a command line interface and you don't want to use an IDE, then you're going to use the same thing. If you're on Windows. If you're on Linux, you're going to use the Unix Makefiles. All right, so now we're going to build. We'll say CMake. And I need to now tell it where to build, and also what generator to use. So to tell it what generator to use, I'm going to say -G for generator, open quote, which is a string. I'm going to pass in the name of the generator from that list I just saw a second ago. So I'll say min gw makefiles. And now I have to tell it where to look for the root directory. And since I'm in the build folder, I have to tell it to go to my parent directory, which is the root folder of the project. So I have to tell it where to go find that CMake file, that CMake lists file. So I'm going to say ... which means to go look at the parent directory. It'll be looking at AI Terrain 2D for that. And then after this, it's going to build it in the default location, which is the current file folder location. I could also designate the build location, but it's easier for me just to leave it here, and we'll go ahead and press enter to let it build. Okay, so here it says configuring done, generating done, build files have been written to with the location. If you get that message, you have successfully built with CMake. And now we have to go ahead and compile our executable by calling another CMake command. To do that, we're going to use the CMake -- build period command, just like this. This is saying, go ahead and create our executables, compile our code with the build that we just created, and put it in the current, or use the current directory as the source directory for our build configuration. So I hit enter on this. Okay, so it built successfully. Notice I went ahead and built my EasyBMP first because I told it to do that one first. Over here on line 26, target link libraries, EasyBMP happens first. And then it builds fast noise second. And after that, it finally builds my final target executable, and it stores that into the bin folder. So to go look at that, I can say dir. I can go cd. Let me clear this out. cd bin dir again, and there it is. There's my executable. So I can call that and see if my code runs. And there's my code asking for me to input a number. So I'll say, I don't know, 6, and then it exits. That's all my code does for now. So this is how you build with CMake using minimum GNU on Windows with a command line workflow. If you have any questions, comments, or concerns, leave a comment below. And then please leave a like, subscribe. Hope to see you in the next one.